The Arctic, they say, is unforgiving, and whoever said that was right.
All right, lock it in, folks.
This mission is an Arctic expedition, but it's also a Mars analog mission, so why is that important? So when you do a Mars analog mission, you have to put into place some protocols that make it seem like you're on another planet. So the place that we were in helps a lot because it looks like Mars and you're in real isolation that far north. But what we did to heighten the simulation was that we had airlocks. We could not go outside without a spacesuit. And we also had time windows where we could communicate with the outside world on a 20-minute delay. So right away, we've got challenges we've got to deal with, and this is just the nature of the area. Devon Island was chosen as a Mars analog because it's a polar desert, so there's almost no vegetation up there. And this particular research station sits on the edge of Haughton Crater. We were the first scientists allowed to go to the impact site in Haughton Crater, and you have to get special permission to do this. So on the way to the center of Haughton Crater, I was on polar bear watch. So this is where certain crew members are responsible for keeping a lookout for polar bears. It's a real threat in the Arctic. And as I was walking along this ridge, looking down into a riverbed where my crew was traversing, I walked up on a rock outcropping, and this rock outcropping had all this life flowing from it. So it had greenery, it looked like water was coming out of it, it had orange lichens on top of it, it had moss. And we came back a couple days later to discover that it was most likely a thermal vent coming up from deep underground. And the difference in temperature had cracked this rock. And we got some geologists on the line with video call, and they were looking at it and they were freaking out. They were like, what is this? This is incredible. So using some of the technology that I brought for Project Phantom, I was able to create 3D models of different rocks that they wanted. So this is really exciting for us because if we're talking about human spaceflight, this is a way where scientists can communicate and guide astronauts when they're not on location, and they can talk back and forth. And I was also able to demonstrate how we could use Project Phantom in the future to use these 3D models to talk to people like these geologists that we had on the line. So it was this incredible experience of like, oh my gosh, if we could talk to people with holograms and 3D scans of things, we create a whole new opportunity for exploration and collaboration. And I gotta tell you what, I'm really proud of this team because we all really banded together and focused on problem solving and kept it positive. We were able to create room for us to do real critical science. I'm really excited about the planetary science that was done because we get to talk about ways to use Project Phantom to help inform those studies. And I'm also really excited about the different lessons learned on how to run these expeditions and ways to improve those as well. The facility was fantastic and it offers an excellent opportunity to do research in the Arctic. And we learned all sorts of new ways to go about facilitating missions like this, which those lessons learned are going to be critical when we do real Mars missions in the future. Analog missions like this, I have a newfound appreciation. Now I can really see what value that it brought. Perspective. And perspective isn't something that you can necessarily get by thinking as hard as you can about it. You have to go live it.
That's what I'm walking towards. Friends, lifelong companions, getting ready to take off into the unknown. So goodbye, Crater. Goodbye, Hab. Hello, sun. Hello, future.